Good morning, students. Next question, 25th one from this ray optics, geometrical optical instruments linked. 25th question, this is not for the CET students, it is related for the CET theory also, and for NEET and JEE it may be asked. Long sighted person has a least distance of distance between, means near point as 50 centimeters. He is supposed to have the near sight as 25 centimeters, but he is having the near sight of 50 centimeters. Long sight means long distance he is able to see only up to 50 centimeters. 50 centimeters to long sight means up to infinity he is able to see. But he has to see from 25 to 50 centimeters in between, not able to see, that also he has to see. So what type of lens he has to use? It is a long sight is corrected with the help of the convex lens. Where do you take the help of convex lens of focal length required f equal to xd by x minus d formula. Object is at a distance equal to 50 centimeters. Okay, and up to infinity is able to see. Up to infinity is able to see. But from 25 centimeters to, that is capital D, we call LDV, least distance distribution for any normal eye is supposed to be 25 centimeters. 25 to 50 is not able to see. That 50 centimeters what he is able to see beyond is taken as a x. Same direction or minus it becomes. So this object should be positioned in the image, should be shifted to the D distance. Then we have to take the help of convex lens. V is images should be formed at distance equal to D, and U is equals to minus x. 1 by f equal to 1 by v minus v. Substitution of the values will give f equal to xd by x minus d. X itself is here, x is equals to, how much you have taken is 50 centimeters. 50 centimeters. That is nothing but equal to, then you, after using the sign convention only you are getting this relation, so don't put again minus sign here. And d is equals to 25 centimeters. This is for the near point. Near point for any normal eye. Normal eye conditions. Substitution of these values will give xd by x minus d. X is 50 into 25 by 50 minus 25. 25, this is also 25 cancels, the result is 50 centimeters. You will get positive, means convex lens. Name of the lens you have to remember. If they ask you power, sometimes it is not asked in this question. Power P is equals to 1 by focal length in meters. In meters, compulsory SI units, which is equals to 1 by 50 centimeters means meters is 0.5 meters positive. So 0.5 plus you will get, that means 10 by 5, which is equals to plus 2 diopters is the power. Next question number 29. Question number 29. This is for all exams. Convex lens has a focal length 10 centimeters. Convex lens means convergent lens. Given f is equals to 10 centimeters. Convex lens focal length is positive. Concave lens focal length is negative. Find the magnifying power for the near point and far point. Find the magnification for image, final image it means, in any cases, image a bit at near point and far point. Near point D, B bit at far point. Far point means infinity. Final image at infinity means object is kept at the focus. Answer, f is equals to 10 centimeters a bit. Final image near point, image at a D equal to 25 centimeters. Magnification m equal to 1 plus d by f. Don't put the sign convention of minus 25 like that. The final expression, what you got this, after derivation of the putting the sign convention, we will get this relationship. Final formulas, don't substitute the sign conventions. Is equals to 1 plus 25 by 4 parentheses 10. D and f are in centimeters only, so no need to convert the units into meters. The ratios, units will be cancelled, which is equals to 1 plus 2.5, which is 3.5. That means image size is 3.5 times bigger than the object side. Because it is a simple microscope we are taking. Single lens acting as a microscope means simple microscope it is. Simple microscope means M is magnification you will get is positive. Erected image you will get. Erected and magnified. More than one is there means magnified. Plus means erected. Next B bit at infinity. Image at infinity. Image at infinity, magnification formula is equals to simply d by f, which is equals to 25 by 10, which is 2.5. No units for the magnification. It is also positive only. Means erected image. Thirtieth question. Compound microscope of magnifying power is 100. Compound microscope magnification m equal to 100. Actually, compound microscope magnification is negative. You will get because final image is inverted. Astronomical telescope also magnification should be negative. They don't mention mine 100. You must know that. Next, magnifying power of the eyepiece. Eyepiece. Magnification of the eyepiece is given as 4. Eyepiece act like a simple microscope. Therefore, magnification is positive. Magnification of the objective lens is how much? Objective lens magnification how much? Total magnification is multiplication of these two, and the magnification of the objective is the inverted image you will get. It is supposed to be inverted image. This forms erected with respect to the object. Therefore, positive you will get. Here, inverted means negative you will get. Object, and total magnification is also inverted. Supposed to be. Answer. Compound microscope. Compound microscope has two lenses. One is towards the object called as the object lens, towards the eye is called as a eye lens. FO, FE. Total magnification M equal to MO into ME is supposed to is given as 100 minus because final image is inverted. MO we want, that means you will get is magnification of the object is equals to minus 100 by magnification of the eye lens minus 100 by 4 minus 25. Okay, let it be. It is a telescope. Without mentioning what type of terrestrial astronomy means, you have to imagine as a Astronomer only. Terrestrial is not in our syllabus directly actually. Astronomical telescope. So go for the astronomical telescope problems only linked. Two convex lenses of focal length 0.3 meters, 0.05, and astronomical telescope, Galileo telescope can be asked only for the JE and NEET, not for the CET. Astronomical only, and mirror with the mirrors means reference telescope is there for all exams. Convex lens of focal length FO is equals to and FE are given to make the telescope. The distance between the lenses is equals to telescope object length FO focal length is equal to 0.3 meters means 30 centimeters. Eye length focal length is equal to 0.05 meters. Where they may not mention eye lens object, they just mention the lenses used. You must know that always focal length object length is greater than that of the eye lens. For a microscope reverse you will find. Due to that reason, if you reverse the telescope, for the telescope object lens has a more focal length than the eye lens. Not the diameter size please. This size is both the cases actually size of the eye only. There we draw the diagram bigger, but no, actually it is size of the eye people. So here in this case FO is always greater than FE. If so magnification is greater than 1, you will get inverted image, final image is inverted. But if you see reverse, if you see from the object, what happens is magnification is less than 1 you will get, means diminished image. Near objects appears as a far objects. When you see the telescope in reverse, it appears near objects appears as a far objects. If you see as it is from the eye lens, if you have seen means near far object appears as near side, looking bigger. If reverse, if you see from here, from object lens side, the near objects appears as a far ones, so they appear smaller ones. Bigger objects also appear smaller one. So your asked is find the length of the telescope. They didn't mention where the final image is formed. When not mentioned, take it as a normal adjustment. Find length of telescope. Not mentioned means just take it as a normal adjustment. Normal adjustment. What is the length is? FO plus FE. L is equals to FO plus FE. If it is not normal adjustment, FO plus UE it becomes. Object distance for the eye lens. FO plus FE, that means 0.3. It is the distance from lens to lens. 0.3 plus 0.05, which is equals to 0.35 centimeters. Sorry, meters given, no. This is also same units, you have to take meters. Magnification they didn't ask in this problem, but magnification is nothing but equal to FO by FE. You can easily calculate that. In 32 question number, they gave the diameter of the lens. Diameter of the lens is only for the resolving power, not required for the magnification. So diameter don't use. You take only the focal length relations for the magnification purposes. Magnifying power of astronomical telescope is 5. It is again astronomical telescope. Magnification is 5. Magnification M equal to 5. Final image is supposed to be negative. Please don't bother with negative sign. That only indicates inverted image. Focal power of the eyepiece is 10 diopters. Find the focal power of the objective. power of eyepiece. Eyepiece is a combination of the two lenses, actually eye lens, eyepiece. Eye lens means single lens will be used, but a combination of one more lens called as a field lens. Field lens plus eye lens together is called as a eyepiece. Eyepiece contains the two combination of two lenses. One is this is called as a field lens, and this is a eye lens. By taking the proper distance between these two, minimization of the aberrations takes place. Chromatic spherical aberrations minimized. Generally, for the laboratory purpose, the eyepieces used are two types of eyepieces are there. I didn't discuss that because it's not in your syllabus in any exams also. Plano-convex lens are used. One is called as Ramsden's eyepiece. Another one is called as a Huygens eyepiece or Huygens. Both uses plano-convex lenses, but Ramsden's eyepiece we have the cross wires arrangement. Cross wires. If you see through this microscope, you will see two wires like this, like a plus, called as a cross wires. With the help of this, you can take the readings, measurements. So if you are taking the readings, measurements, we have to take the help of Ramsden's eyepiece. But for biology purposes, dissection purposes, you need a clear image only. But Ramsden's eyepiece, cross wires are there, please, but not much clear. It is not much clear compared to Huygens eyepiece. Clear only, but not much clear like compared to Huygens eyepiece. And cross wires measurement is there means we use for the measurement purposes. It measures. Small aberration is possible here. Small aberrations. Not clear image means aberrations is there. But Huygens eyepiece, no cross wires, no measurements. We cannot take the measurements without cross wires. And less aberration, clear, most clear images. Most clear images, no aberrations, completely spherical aberrations, and chromatic aberrations are removed. No aberrations. So clear image you will see. This Ramsden's eyepiece in the physics lab you will find a traveling microscope. So in physics lab we are going to use measurements. So that there we use the Ramsden's eyepiece in the readings purposes to find the refractive index of the glass slab. We are taking the images top and bottom. We take the help of the microscope called the traveling microscope, which can be moved left and right, up and down. And there we have to focus this cross wires on the particular position, and again you move the telescope to the new place, microscope to the new place. Telescope means parallel rays should be received. Microscope means diverging rays uses. And if you take the two different positions, the distance between these two can be measured. For that purpose, to locate the points, we take the help of the cross wires. But in the biology lab, you will use, by this bio lab, use Huygens eyepiece. Biology lab microscope, you are going to use Huygens eyepiece. These are the main two types of the eyepieces, but many other types are also there. Mostly used are these two. Focal power of the eyepiece is 1 by focal length of the eye lens or eyepiece is equals to 10 diopters. You are asked to find focal power of the objective is how much? Objective lens equal to how much? Magnification is given for you. Magnification M is equals to F4 by Fe. Magnification is equals to F4 by Fe, which is the reverse of dash. To find out that. From this we can get the focal length of the eye lens and the eyepiece is reverse diameters. Power, if you want to take it, this is nothing but equal to 1 by focal length. So power of the eye lens by power of the object lens, reverse you will get, which is equals to power of the eyepiece is 10 by power of the object lens we need to find out is equals to magnification is 5. Total magnification is 5. Negative means what? Inverted images. Power of the object lens is equals to 10 by 5, which is equals to 2 diopters. Negative means what is? Sorry, we should not take a magnification formula for powers we are finding means concave lens power is negative. So don't take please minus here. Take only the magnitude. Sorry. Final image is inverted, of course. But finding the focal powers, so you have to be careful with the focal length, because focal length is positive only both the cases. Magnification negative or positive only indicates that inverted or erected images. Plus only you take diopters. If the microscope's eyepiece are mentioned as 5x, means magnification is 5 times. The eye lens magnification is 5 times, means 5 increases by 5 times. Whatever the image formed by the objective increases by 5 times, it means to say. Other similar problems you can easily work out. Next, level 2, 62 question number. Two plane mirrors L1 and L2. For right mirror in the figure, they parallel each other 3 meters apart. Plane mirrors, parallel plane mirrors L1 comma L2 have separation 3 meters. Have separation 3 meters. A person is standing 1 meter from the right mirror. Person is at a distance 3 meters from L2. Figure is given for you actually. 1 meter, sorry. 1 meter from L2. The second nearest image in the right mirror is situated at a distance of. Find the distance of second nearest image from L2. Second nearest image from L2. Number of images formed, formulas are there, that I will discuss later. This is theta is the angle between the two mirrors. If any object is kept here, number of images formed is nothing but equal to 360 by n. And minus 1 also you need to take some times to convert that even to odd and vice versa. This n, sorry, by theta. If the plane mirrors you have taken parallel to each other, when parallel mirrors you have taken means theta is equals to 0. This is for parallel mirrors. Theta is 0. Anything by 0 is n equal to infinity you will get. So that means infinite of images are formed. This arrangement you will find in the barber shops, and also that means hair cutting salons. If you see backside one mirror is there, front mirror is there. Image forms, the image formed first mirror reflected by the second mirror. Again this also reflects the images here. So multiple images are formed in the mirrors up to infinity you can find it. Each one forms the image, continuously that process goes on. Same thing in the switch shops, so they will keep two plane mirrors are kept front of others, so that you will see the switches of large numbers. Even the small number is there, they make us to see the large numbers. The further arrangement we take the help of the plane mirrors which are parallel to each other. Two mirrors are given for you. One is L1, L1 is L2, plane mirrors. For plane mirror, object distance equal to image distance. Person is standing here at distance equal to 1 meter, and this distance is 2 meters. Total is 3 meters. And because of 1 meter, no, image is also formed at distance equal to, this is the first image, I1. Distance 1 meter equal to, this is also 1 meter distance formed. This is also 1 meters. And here the image formed is 2. So here at distance equal to 2 meters. This is the image for the L1 at distance equal to 2 meters. Its image is this is a I1 prime. This image acts as an object for the second mirror, and distance, image distance equal to object distance. Again one more image is formed here, that is I2 because of this image. But what is the distance from here to here? From here to this image is nothing but equal to 3 plus 2, 5 meters. So from this mirror distance equal to 5 meters. This is nothing but equal to I2 prime is formed. This from the mirror it is 5 meters. Question is, how much is the distance of image they asked? The answer is 5 meters from mirror. From the person if they ask, 6 meters. Second image distance, they ask nearest image from person, because options are given from the persons. Image distance, second image distance in L2 from person is equals to 6 meters. Next problem. I will not do the order because time is less for this. Okay, we can merge it. Question number 63. This is important for NEET and JEE, not for CET. Infinite long rod of infinite length is on the axis of the concave mirror. Rod of infinite length is on the axis of concave mirror of focal length f. Near end of the rod is a distance u greater than f. Near end of rod is at distance. Near end of the rod is at distance u greater than f, means object distance more than f means you will get the real images. Less than f means virtual image. Greater than f from the mirror. Its image will have a length. The mirror. Find the length of image. Find the length of image. So this is a concave mirror. Linked to this problem, only diagram linked problems can be asked for the CET also, not problem solutions type equations, but diagram, nature of the image formation can be asked for the CET. You have to identify which is the correct image, like that they will ask you. So here the focal length I will take up to here. This is nothing but equal to f. Object is beyond the focal length. So up to infinity, infinite long length is there. Rod is kept here. Up to infinity. This is not the end. Up to infinity means we will cut like this. This is up to infinity. B is at infinity. And this is A, first point. Starting point is A. This distance is nothing but equal to U, object distance of this A. This is the object rod. And this is nothing but equal to F, focal length. This is a focus point. When the light rays are coming from infinity, they must pass the focus. Means object at infinity forms the image at focus. And at A, you have to calculate the relationship of the image distance. 1 by f is equals to 1 by v, 1 by u plus 1 by v terms. Where is the image formed? Is this is the object rod, and image will be below this. You will find when object is at A, that is starting point, beginning point of this rod, image is at infinity. Image forms the the end point which is at infinity forms the image at focus, and the near point A forms the image at a finite distance. So you are given already the distance of point A, beginning point as U is given. I will take it as a UA. UA is nothing but equal to U. It is given for you of the distance, and image distance at infinity B forms the at focus. So VB, image distance of B becomes equal to F only. But point A is forms the image at some distance, finite distance equal to VA, image distance of the point A, and inverted. That means this point appears as a point here. For the end B at UB and for the end B at infinity, the image is at focus, VB equal to F. But second point, that near point is UA is greater than F, near inverted, this is a real image and inverted image, real and inverted image is formed. So 1 by F equal to 1 by U plus 1 by V for the mirrors formula. For lenses 1 by V minus 1 by U, for mirrors 1 by U plus 1 by V is 1 by F. Okay, and values are not given, don't take the sign convention again for these two cases, just take the basic formula. From that only we have to get the expressions required. You have to find out F is given for you, U is given, you have to find out V. So 1 by V equal to 1 by V, 1 by F minus 1 by U it becomes. Taking the LCM of this, you will get the expression for VA equal to UA into F by, you have to be careful, reciprocally you are getting it, so reverse it, UA into F by UA minus F you will get. Length of the object initially given is infinity, but you have to find out length of the image. This is the length of the object is infinity. Length of the image you have to find out means the distance from here to here. This distance from here to here, again VA, VB you are getting it. So VA minus VB is nothing but equal to length of the image. This is nothing but equal to length of the image from here to here. That is VA minus VB, image distance of the A and B. Difference of these two will get no. You get the expression as F square by UA minus F. UA is given as U, so take it as U minus F is the answer for us.